I think it's here.
Is it?
Yeah, I see it. It's
then we should be good. All right,
All
go
right.
for it.
Well, thank you. Sorry for the technical difficulties this morning. Thanks for coming, everyone. I'll start with highlights like usual. I think a pretty big one. I was surprised to see that we actually forked and created a new repository for the Rev API plugin. So thanks to everyone who's been working on that to allow us to continue using Rev API through Gradle. So JB, Ajanta, Edward, I also saw a Moog with some PRs there. So thank you guys for doing that. That's actually like a lot more broadly useful, hopefully to other projects and not just us. So that's pretty cool. Thanks, guys. The next one I wanted to highlight, Manu recently added a executor so that we can parallelize the file listings in snapshot and migrate commands. So really nice to have that rolling because those commands can really take forever if you don't parallelize that listing. So thanks, Manu. As usual, I think we keep thanking Manu on these, so really cool to see that. We also added, so this is dramatically, or Steve from Apple, added pushdown for data file content filters when scanning the entries metadata table, which is pretty nice because you can do some things like skipping entire manifests if they only contain deleted files and things like that. And it's kind of just annoying to do those pushdowns, but really good and nice to have. Sorry, who?
Ryan, do you want to share? Do you have two screens?
I can screen share the notes.
Yeah, I was gonna say that way you can even like highlight what you're looking at and talking about. That'll be good for the video playback as well.
Let me make sure I can do that.
And if not, I should be able to get
profile.
Okay.
All right, here we go. Can you guys see those?
Yeah.
All right, cool. Adjust some things. Pay no attention to how many tabs I have open.
Oh, that's too late. We're all judging you.
All right, here we go. All right, next. I want to thank, I always get this name wrong, Huaxin, I think, at Apple, for adding aggregate pushdown for incremental scans. So that's a really cool thing. Aggregate pushdown is something that is really really handy because if we can satisfy a query entirely from metadata, it's way better to do that. So really great to see that continuing to go in. Then Fangjie for improving some Flink performance things. So we've seen this issue several times in the past where if we need to create a projection or something like that and you don't reuse the row, or if you need to create multiple rows, it can take a long time because we need to locate field IDs and build accessors and that sort of thing. So by pre-creating field getters, we're actually able to save a bit of time in the Flink path. So that was really cool. And then finally, I want to thank Alexandre. Am I pronouncing that right? Alex Dutra. I'll just go with Alex next time. For getting in the PR to remove the credential override in table sessions. So this was when we're creating a table session in the REST catalog, we usually take some of the security parameters from the properties that are sent back with the table and merge them in so that we can do things like authorize an individual table file IO with the user's permissions for a table. But that was also inadvertently allowing the service to send back a different credential, which doesn't make a ton of sense, and override the credential that the client uses, which should not be part of that interaction with the service. So After some good discussion, we determined to remove that credential, and so thanks, Alex, for removing that. All right, and I'll hand it off to Faco for the Python. Oh, sorry, I want to mention one more, which Zhang added. We can now pass read properties via Spark SQL, which is great. We've been wanting to do this for a really long time. I know that we tried to get hints in, and it's great to see just a new clause in Spark SQL for passing those read properties. So thanks a lot, Zhang. That's a really good one to get in. Not in the Iceberg project, but definitely helps all of us here. And with that, I'll pass it off to Faco.
Thank you, Ryan. Yeah, so big shout out to Zhang, who actually implemented the streaming batch reader. So he was running into issues where he has very well compressed Parquet and it blew up in the memory. And using this new API, you can actually stream per batch the data from Iceberg into Arrow, which is really exciting. And thanks Hannah for working on the merge event. It actually also uncovered a couple of bugs, so it's very good to get in. And also he also smoothed out some APIs there. So big thanks for Hannah. Now we can actually we had like only fast appends before, which create like a new manifest on each write. And now we also have the merge appends where we actually combine the manifest into the other manifest entries into the manifest list. So that's also really nice. Yeah, so on the Rust end, Centomé actually worked on the field IDs, writing into the Avro files. So this is the big blocker for the new release. I already created like a pull request just to make sure once the Avro release gets out, we can come to the latest version and go from there. So that's also really exciting. I think that's it for me. Back to you, Ryan.
Awesome, thank you. And I will start the releases section, and I'll hand it off to JB to talk about what's remaining for the 1.6 release.
Yeah, so about the 1.6, the main pending pull request is about the commit coordinator. So we got basically we have two pending pull requests. When I checked this morning, it was one which is a fix on the JDBC catalog about namespaces containing with characters. So this one has been reviewed and approved, and I think that it's merged now, as far as I remember. I have to double check. And the second one is about the commit coordinator. So yeah, that's the only pending. We also discussed with Foco earlier today about Avro releases. And for Java is not a blocker. It would be good to have, but not a blocker. I'm pushing with Foco, I'm pushing on the Avro release mostly for Rust, not directly for Java this time. So yeah, the blocker is really about commit coordinator. If we can move forward on this one, that would be great.
What's the issue there?
Just I guess latest review round and merge.
Ryan, this is the Kafka Connect, so it's like a huge PR.
Yeah, it's all reviewed and ready. It's just a matter of getting a committer approval, I think, at this point.
Yeah.
Okay.
So we just
yeah, I think so.
Sounds good. Dan, are you on top of that one?
Yeah, I got that on my list.
Okay, cool. And I assume that this is just so close that we think like may as well get it in so that we get this Kafka Connect stuff out.
Yeah.
Okay, yeah, because we don't typically want to block for new features, but that sounds good. Okay, and who wants to talk about the Iceberg Rust release? Is there much to update here since it's still waiting on the Avro bug fix for IDs?
No, there's not much. Just like I know a lot of people from the community are waiting for it. So just an update, like we're almost there. Just have to get the Avro release out, and then we can start the RC process. So
okay.
That's great.
And I'll just. Oh, sorry. Go ahead.
Sorry, Ryan. For the Rust Iceberg Rust release, we need 1.11.4 from Avro, right? No need to do 1.12, or do we need 1.12?
The 1.11 and 1.12 is more like a Java thing.
Yeah.
So I would say, like, I think from Rust we can just create a release from main, so that would be 1.12, I would say.
Okay, cool. So So everything we need for REST is already included on the Avro main branch, right?
Exactly. Yeah.
Okay, so good. We can move. So just to let you know, I'm pushing on 1.11.4, as you know, which is super painful in terms of build. So I think we are good now. And as soon as 1.11.4, I think probably Focoa will switch to 1.12 in the meantime, just to unblock the Iceberg Rust release, because it's not a blocker for the Java one. So, okay, got it. Sorry to interrupt. Thanks.
No worries. All right. And Faco, do you want to raise any issues that are pending on the 0.7 release for Python, PyIceberg?
Yeah, so we're actually wrapping up some last stuff with pushing down some PyArrow details. So in PyArrow, you actually have like a lot of types, and a lot of them do the same thing. For example, the string type and the large string type. And we now do some passing over there on the internal PyIceberg. And I'm still with Zhang. We're looking into either make this behavior consistent, or just make sure that we push it all the way down to PyArrow, so we don't have to care about it. So that's something we're still trying out. We had like a PR on the Arrow side being merged yesterday. I checked out the label release, so we also run into some issues with that on the Arrow side. So so that took a bit more time than we anticipated.
Got it. So Arrow, it sounds like, has just a lot more physical types and doesn't really map into the small set of like SQL types that we use.
That's correct.
Okay, makes sense. Cool. All right. I'm not sure about the progress for proposal guidelines, or sorry, progress for project guidelines. I think we have discussed the the project improvements and that. So anyone want to jump in here on?
Yeah, I think I added that one. Sorry, I think I added that one, and this is about that bylaws thread, and I think it has been making pretty good progress so far. But last week, Owen said he want to be the moderator, and then there was no any further action from him. So I'd like to know what is the next step we think should take.
I think it is that he wants to help us moderate this. I had some personal interaction with him, and I think he just got sick. So we're just waiting for him to get back. So I wouldn't worry too much about that. But yeah, it was nice of him to volunteer to moderate. So
sounds good.
Awesome. All right, so the next thing up is discussion, and I think it said, if helpful, Geo Support Overview, and I think that's a great thing to dive into. We've been meaning to get to variant and Geo stuff for a couple weeks or a couple meetings now. So yeah.
So I didn't know whether we wanted to have a separate meeting, but I can go over like a few minutes, like a very quick overview, just so I think take advantage of the fact that a lot of people are here. So can I share my screen quickly?
Yeah, you should be able to. I think I'll stop.
Let me see.
Let me know if you can't.
Okay, I think that's good.
There you go.
Yeah. I'll spend like maybe 3 or 4 minutes, and we can have a more in-depth meeting. But I think I wanted to go over it because I think where this proposal got a lot of feedback from geo domain experts, I think it's a bit hard to ramp up for Iceberg community. So I just wanted to give like an overview for this this proposal. So first, the background is that like a lot of open source projects in the big data space have been adding geo support either through extension points or natively. So these are the ones that do extension. These are the ones that are natively.
Zhang.
Yeah.
Would you mind zooming in?
Yes.
It'll be better for the recording and for anybody watching now. Perfect.
Okay, cool. So some projects have been adding it via extension points, and other projects have been very currently, recently adding it natively. And Iceberg is in a unique position where we're used by a lot of projects. It's a very central point, so it makes sense to add it, but we don't have extension points. So then right now, the only people who are doing Geo and Iceberg have been forced to fork the project, which is not ideal, right? So we wanted to, so this proposal is actually based off of a lot of work from these two groups. One is the GeoLake research paper, and one is a company called Werobots, which has the proprietary implementation forking Iceberg. And they actually helped me contribute a lot to this proposal. So just a little background on that. So the use case, I guess this is more interesting to people. Like, what does it mean for Iceberg to share to support geotype? So in the end, the user will be able to create a table with a geometry type using a geometric partition function. You're able to insert geometric data. So I'll go over that a little bit in a second, but this is like what geometric data looks like. You're able to use geometric sort ordering to kind of like make your files more optimized for geometric queries. And with all that, like the partition transform and the sort ordering, we're able to push down geometric predicates down to the table to answer queries quicker. And in the geometric world, I guess it's mostly physical, like does this geometry cover any geometry from this table, or does it intersect this kind of thing? So that's kind of the end goal of this proposal. And yeah, so I'll just, I'll just go over quickly. The geometric type is the biggest thing to be added to Iceberg. And this is all very standard from OGC. It's an Open Geospatial Consortium. Basically, all the open source projects have been following this standard. And so the geometric type is kind of a super type of these other things like points or polygons or lines, which are like geometric objects. At the end of the day, all the geometric objects are just a collection of points, which are two doubles. So you can think of geometric type kind of like as a complex type in Iceberg. And then there's a lot of discussion, but a lot of it is actually centered around like what we could support later. Geometric types, there's like different systems. Some of them specify different properties on the type. For example, coordinate reference system, whether edges are planar or scalar. I think for the sake of getting consensus, I think these could be pushed to phase 2. For phase 1, we only support like the default values for coordinate reference system and edges. So I won't have time to go over that. And then the encoding is another interesting part. That's also kind of well documented, the standard. So the OGC specifies this thing called WKB, which is one-on binary that serializes all these geometric objects into a binary string, and we'll map that to a Parquet byte array. That's the idea. The downside of that is that there's no way to get very meaningful min-max statistics if it's just a byte array. So then the second proposal, or this is the first phase. The second phase, we were working with Parquet community, and there's a Parquet proposal out to support geometric as a first class logical type. And with that, we're able to persist min-max geometric min-max statistics as well on the geometric logical type. In the geometric world, it's called bounding box. So instead of like a min and max for one-dimensional, it's more like a two-dimensional or even three-dimensional where you have min-max of like x, y, and possibly z coordinates. But it's essentially the same thing. So yeah, with that, we will be able to, once the Parquet support is in, we're able to take advantage of that format, and then roll up those Parquet level min-max statistics to Iceberg to allow further predicate pushdown. Yeah, we'll target Parquet initially, and then we might support other formats later. There's only 3 express predicates that we want to add to Iceberg, which is like as I mentioned before, like does this geometry cover this other geometry? Is it covered by this other geometry, or do they kind of intersect? So you can think kind of physically these predicates. And so on the Iceberg side, we would have to add these predicate methods to all the visitor methods. So every time we evaluate, like manifest or manifest entries or residuals in the Parquet row group, we would have opportunity to evaluate these predicates based on the statistics. And then I think the last thing I'll talk about is the partition transform. This one is a bit the trickier part. We do want to have a geometric partition transform, but a lot of the traditional ones out there, like the Google S2, Uber, H3, GeoHash, the problem with that is called the boundary object problem, because these geometric objects may kind of cross a physical cell boundary. So in the end, like one geometry may map to different partitions, which is not supported in Iceberg. So then the Wearabots and the GeoLake has done something called implementing XZ2. This is a research paper, and basically it takes advantage of the fact that you can have overlapping physical quadrants. And so this deterministically makes every geometric object map to only one partition value. So it's kind of a complex paper, but I encourage people to kind of read that one. So yeah, this is just a proposal how we would implement that in Iceberg. We would have a geometric XZ curve partition transform. And this would do two things. It would map a geometric object to partition value, obviously. And then the second part is to kind of, like we do today, project a user predicate on a predicate that can be evaluated on a manifest file. And this is just kind of explaining how it would do that. Geospatial sorter, I guess I'll just one more minute and I'll finish up. Geospatial sorter, so I think there's already, rewrite data files takes in a sort order. We would just implement a one that takes in a geometric column as a how do I say, as an input. And then probably the Hilbert curve is the one that we would target. And then, yeah, there's algorithm how we would implement that. But essentially, this would kind of make, just like we have today for one-dimensional data, be able to get files with more compact bounding boxes so that the predicate pushdown could have more effect. And then this is probably the one that's a bit more like up for debate. So right now, Wearabots, is the company behind Apache Sedona, and so there's already a big community. Sedona is like a Spark extension point. So all these types and functions that we define in Iceberg, they kind of have to go up to Spark. And so the problem is that they may conflict with the Sedona defined like types and geometric expressions. So then the Wearabots engineering has proposed this kind of interface that like we would load by default the Iceberg types, but if Sedona is enabled, the Spark side, we would have an interface to load like a Sedona Spark types and Spark expressions. Yeah, so I didn't want to take too much time, but just give it a quick overview of that. So hopefully that's clear.
Thanks. This write-up is like really great. So I encourage people to go through it in a lot more detail. This is, I think, one of the bigger projects for the next version of the Iceberg spec. So really cool to see this. I think solidifying and getting to the point where it's a lot more defined. I think a lot of the open questions at first have been solved, so that's really cool. I do have a question about the use of well-known binary as well as GeoParquet. Do you think that that's a necessary phase to do the well-known binary before diving into GeoParquet, considering that well-known binary are going to produce those min-max stats?
Right. That's a good question. Oh, by the way, it's a terminology. GeoParquet is not the thing we're using. Like GeoParquet is an extension of Parquet. The second phase actually, right now, Parquet community itself is adding native support. But yeah, that aside, I think it's, initially we were thinking that would move slow because, Parquet project typically moves kind of slow, but looks like it's actually moving faster than this proposal. So we might be able to take advantage of that. If it's not out though, I think it's kind of a quick migration wherein, first we would assume it's our own type, and then later we would just add a check if it's annotated with this Parquet logical type. We could deserialize because it's the same bytes in any case. But yeah, I think it makes sense. If the Parquet one moves faster than this one, we could just directly go to that. Yeah.
Well, I'm also just concerned about the additional requirements in the spec, right? Because if we say you can write well-known binary as well as the Parquet native type, then we're probably going to get, or the logical type. I mean, if we can just define the Parquet logical type here and then push it upstream, then that actually helps us because we only have the one format to worry about, rather than saying like, oh, it might be binary or it might be this other thing. So I probably recommend trying to keep that simpler.
Sounds good. And if there's Parquet committers in this group, maybe that'll help if you guys can also try to help on that.
Yeah, I think we can.
Yeah, thank you.
Dan?
I just wanted to ask about whether or not the teams that are behind this are supporting other languages and implementations, because a lot of these changes will have implications for like the Python, the Rust, and if we want to incorporate all of the visitor changes and other things like that in those other languages, do we have any sort of library support for the geospatial types?
Yeah, I'll have to get back to you on this one. I have not.
So I'm here. So
Yeah,
I think I can take this question.
Yes,
Yeah, so I think this is a great concern. So before we draft this proposal, so we have studied the language banding in different geospatial support in different languages. So in particular, most of the geospatial library in different languages, they all come from the same source called GTS, and it has many different language bandings, even in Rust, in C++. So, and also the license of these libraries are very friendly. So they're all compatible. Most of them are, I think most of them are very compatible with Apache Software Foundation. The only concern here is about the CRS. So that's why we didn't add it in this phase, because currently, in order to pass the CRS definition, so we need to rely on a library called prod.json. And this particular library is only available in C++ and Python. So that is the concern here. That's why we didn't add it in this phase.
Right. So that's a phase 2 item, I guess, waiting on language support.
Yeah, I think the bigger question is just kind of like general compatibility. Like, I'm not sure I would like hold up like moving forward with Java unless it actually causes problems where like you couldn't plan or even interact with the table in a different language, even if you want to ignore the geospatial types. If they just show up as binary or something else, I think that would probably be okay. But especially if we're going to be doing something special with either the min-max stats or changing partitioning in a way that would be incompatible, we just want to be really careful that we don't just like break everything that adds a geotype.
Yeah, that makes sense. We'll definitely evaluate whether there's any danger of that.
Another thing that I wanted to raise here that I put on the agenda was, I know that I think it's Havasu added column bounds to the manifest list in order to basically be able to do these bounding box intersection sort of queries at the manifest list level. I know you guys are considering the XZ2 to fit more cleanly into Iceberg's idea of partitioning. Is there still a desire to do the bounding box intersections at the manifest list level? I think that there are possibly other use cases for the bounding box stuff at the manifest list level. So I'm wondering if we should start thinking about adding that as well for not just this, but other use cases too.
Yeah, so this proposal was trying to fit it more into current Iceberg. So yeah, this was not in the proposal to take that part, but I mean, if you're saying that there's other use cases, we could also evaluate, reevaluate that.
Yeah, I think that there might be. I'll look into it. But the more actually, this was Dan and I were talking about potentially using manifests as manifest lists. which would get us that sort of for free, because what you would be able to do is track a manifest within a manifest and have sort of a more generic tree structure. So that's been, in my head, and that would, would support this work, I think, because we would have the ability to do those like bounding boxes.
Okay.
So I'm just curious if we think that the XC2 partition transform is sufficient, or if we're going to need, in a further phase, right? I think like this is a good scope for the initial phase, certainly, like getting geometry type in and some of those things. I'm just wondering about, what the next steps are.
Yeah, it sounds like that could be a nice addition in generally, and also for this one as well. But yeah, just think about that manifest as manifest list.
Yeah. Not sure if anyone else has thoughts or opinions there, but it's kind of
I think that, like, those use cases are gonna come up more and more as you get into the geospatial types, because you're gonna be doing things like calculating overlaps, and that won't necessarily work great with the current partitioning structure. Like you want the full statistics, or so I think that like more of these use cases will emerge, and I can imagine geospatial will need it faster than most other things.
Okay, yeah, I'll definitely think about this one. Didn't cross my mind. Yeah.
Cool. All right. I think let's get back to the agenda. Let me pull it up here. Okay. Next, present again. We've got, I wanted to review and get back to some of the spec changes that we've been talking about in the table spec primarily, because we've been talking about V3 for a while. And, I know that the other thing that was suggested here is, relative paths in Iceberg metadata. But we've also got the variant proposal that we've been putting off discussing for a long time that I think a lot of us want to get in. And then the additional types, timestamp nanos, which I think needs another review. Fitting the document to my screen.
Yeah, if you click on like view, or even that, yeah, the zoom should be able to fit. Or yeah, there you go.
All right,
there
we go. So, one thing that I wanted to get here, I think, does anyone want to talk about variant first of all, because we've been putting that off as well? I don't think we have Tyler here.
Yeah, this is oh, sorry. Yeah, this is Alpha from. Can you hear me? Can you guys hear me? Okay.
Yeah, go ahead.
This is Alpha from Snowflake, and I'm working on data lake Iceberg integration. Yeah, actually, we work collaboratively with variant data type team and trying to bring the variant into Iceberg Spec. Okay, yeah, maybe that's better to share screen. So maybe I can give like a brief introduction on the variant data type. Snowflake supports variant data type natively. As we move from add support to Iceberg in Snowflake, the customers actually also want the same support in Iceberg. So that's why we kind of like try to propose to add the same data type. Actually, like not only Snowflake, we also find out like Redshift also have the similar data type support, and Spark actually recently also add variant data type implementation. Yeah, hopefully that is easier to understand comparing to geotype. So yeah, so basically, within Snowflake, this is kind of like I guess it's kind of similar within Snowflake, and also what we have, what Iceberg has implemented. So it has like a variant data type, and that is kind of like similar to like JSON, but it's kind of like superset of JSON. Yeah, can you scroll down?
To the examples or to
Yeah, here, just one kind of example. So here, like we use a JSON example. Basically, you can parse JSON into a variant data type. So you can see, well, of course, for Snowflake implementation, it's not only to support JSON, but it's a very common case is like, a lot of users support JSON. For example, like you can support XML as well, right? Yeah, can you scroll down?
And I think one of the, if I'm sorry to jump in.
Oh yeah, no problem.
The differences between JSON and this is that the variant type would actually embed some, or have the ability to embed some type information. So
yeah, that's correct.
You might get a timestamp typed value out when you do a variant get. Is that correct?
Yeah, that's correct. That's correct. So basically, it like for JSON, right? It's more like string or int, right? But for other data types, it's more like you convert that into string, in JSON, right? But for variant data type, it has more support more rich data type. Yeah. Yeah, of course, like if there's some questions I cannot answer, I'm gonna our Cellcutor, which is from data type team, they work on the internal implementations. So he will have like way more knowledge than me. So if I cannot answer, I can. He's out of office, so if I I can. If I have more questions, like I can discuss with him and reply in the doc. So what I will propose is not only to support like JSON, but it's for like any type of like including scalar values and also some of like complex values, including like array and also object or key value pairs. So basically, any data, kind of like any data types can be converted and loaded into variant type. Yeah, can you scroll down further?
Or past?
Yeah, just right here. Here, that's kind of like the functions or expressions we want to we're thinking of like to support. Basically, this is to like convert to convert to variant or pass out from variant. Yeah, so you can convert different data types into variant. It really depends on like what kind of formats like we want to support. For example, if you want to support XML, then we need to add additional functions in here, to convert that to a variant. Actually, since like Spark already has an implementation, so we kind of like try to align with the open source Spark version. So we kind of change it a little bit in here, which is like different from Snowflake implementation. Snowflake format. Yeah, can you scroll down further? Yeah, so it's in here. Yeah, in encoding. Actually, for variant data type support, the major discussion here is, how to encode how to encode the variant. Yeah, the folks have like put a lot of comments in here. What kind of like encoding we should evaluate. Our data type team actually evaluate and compare, like Spark variant versus Snowflake variant and some others like BSON. So what are we, instead of like Snowflake variant, actually it's pretty similar to like Spark variant. So so instead of like propose a new encoding, right? So we're gonna try to propose like Spark variant as a binary encoding, which has like benefits like maybe we can take the Spark variant encoding implementation and then directly using from Iceberg project. So that's why we're kind of proposing Spark variant. Of course, there's some like some other difference we also mentioned here, but we figured like Spark variant probably maybe it's a better comparing to like JSON-B or BSON. Yeah, can you scroll down further?
Here or further?
Yeah, maybe even further. Yeah, here. So yeah, here we kind of course like the major like Spark has a full spec you can refer to. In here, we just like mentioned kind of a high level like how encoding looks like. Give you kind of a overview, especially like for the major one, for struct and arrays. I think that's not much surprise in here. Yeah, but maybe you can, you guys like can take a look for the high level overview. Yeah, and also scroll down. Here, we kind of like compared BSON and Spark variant to capture the difference between these two. Of course, and there are some kind of like pros and cons, but yeah, we just kind of like listed in here. Can you scroll down further? Yeah, and we have some like comments to ask to evaluate the Amazon encoding. We also kind of include in here, try to compare. But basically, we have to like choose one of the encoding algorithm and support. And we try to capture the better side of all those kind of encoding algorithms. Can you? Yeah, another like we have like comments on like what kind of like type interface we should support. I think like BigQuery actually only support JSON, and this, we also evaluate like some other, as we mentioned, like like Redshift, like super type actually is kind of quite similar to Snowflake variant, which is support many other types actually. From Snowflake, customers actually they really want the same same kind of support, like as we supported in native Snowflake format. So I think we are proposing to, let's say, we can support JSON and a variant type, and like we can choose to like the engines can choose to support JSON only or support JSON and variant. Actually, that's not much additional work to support the full variant So that's why we think because like underneath, right? Like it's roughly the same like encoding mechanism, and also like it will bring the parity between Snowflake and Iceberg data Iceberg format. So that's why we kind of like compromise to say maybe we should support both like JSON and variant. Yeah, can you scroll down further?
I have a question on that subject, actually. Like, I'm not quite clear from the proposal you saying that at the Iceberg level, we support both JSON as a type and variant as a type, but the underlying representation is just the variant representation. We're just putting like a restriction on the JSON one that it has to be JSON compatible, whereas variant is broader than that. Is that what you're saying? Or are you like two different physical representations?
Yeah, well, actually, it's gonna be like if you only support JSON, right? Then you have a slightly small set of like encoding support. But for variant, you need to like support encoding of like timestamp to encode separately, right? For JSON, you don't have to support that timestamp, but for variant, you have to encode that differently.
Yeah,
so it's kind of like a little bit additional support.
Yeah, I'm just thinking that like, hey, if we're gonna do variant, then you've already got a superset of what is JSON. So why wouldn't you just say, well, the JSON representation is just variant with the extra restriction that it has to be valid JSON. So you don't have two different implementations of encoding.
I think another alternative there is to have a way to interpret certain values and convert to JSON. So you could say, like, if we have a timestamp, then that shows up in a JSON representation as a ISO 8601 encoded timestamp string, and that way we have a mapping to and from JSON and variant. You can always read a variant column as JSON and know exactly what you're going to get.
Yeah, that was my second question, which is, I think this makes a lot of sense, and I'm a huge fan of introducing variant, but for languages that don't support variant or don't have syntax, like, is there a mechanism to actually do that translation to JSON, which would be something that most things like even like PyIceberg and Arrow could actually operate on, independent of the actual variant type. So it sounds like, Brian, you're saying you think that there is a clear way to map from variant to JSON, or is variant such a huge superset that, like, hey, the XML support or something like that could not be mapped to a JSON representation?
So my thought, and I know Russell's gonna want to say something too. Like, my thought is just define how to convert from different types to the set of JSON types. That you have a very specific, like, I'm reading this as JSON. You need that anyway, because if a table has a variant column and your engine supports JSON, you need to be able to read that column. So, like, I don't see a benefit to doing that unless we have some benefit in restrictions on writing data into a column. Sorry.
Yeah. No, I mean, I agree. I think that's the only place where it really matters to have the two definitions, because unless we're doing the validation, which we're probably not going to be able to do anyway, because we don't control clients in that way. So, I mean, if your engine only supports JSON type, you end up only being able to write JSON. That's kind of it. But if your engine supports variant type, you can write whatever you want. And when we get it back out, we have to just do the same game we've done with types that aren't globally supported before. Like with UUID, we would map out to a string or whatever. And I think that's fine, because if your engine can't deal with that type, it can't deal with that type. You'll get something back, but like, you might not be able to do anything with it.
And I think it's important that what you get back is the same across engines.
that we can try our best on, right? But yeah.
So
I mean, worst case, you give the binary representation that we've defined and dump binary back in the field that we can't translate.
Okay, because that was kind of my question, is like the expectation is if we had a JSON type clearly defined as an iceberg, like the expectation would be you can deserialize that into a string representation for anything that doesn't have like native JSON support. But with variant, we don't have that expectation. Like if it is a variant type, we can't say, oh yes, we can map that to JSON for you because it can represent things that can't be mapped to JSON. So that's kind of the big question. I wouldn't necessarily say, I think it's actually more in favor of like, hey, let's support both JSON and variant so people can be clear that like when they're talking about JSON, it's actually JSON and everything understands that, as opposed to only doing variant and then people assuming that it's JSON when it potentially isn't.
I guess my only worry is we have an engine that doesn't know the difference, right? Like only supports variant and doesn't support JSON. That engine has no way of putting in those rules of knowing that this is like a JSON and it has to validate that.
Yeah,
I think these are kind of edge cases, though. I don't know if it really should matter.
I agree. Like I would put the restriction on the engines that don't support the full variant type rather than, or like put extra requirements on those for reading rather than requiring everyone to think about like, hey, should I convert this timestamp to a string before writing? I don't think that we want to do that necessarily.
Yeah. Yeah, I mean, like, feel free like to add those kind of like questions in here. Like, if I cannot answer, I gotta check with data types team and then try to get back to you guys.
Awesome, thank you. I think.
Yeah, actually, and one more thing is like sub-columnization, like which is kind of like additional performance improvements actually. Initially, we thought that we're going to separate this into the following spec. So basically, that actually Spark already has a proposal. Basically, that is like to separate a subtype, a subcolumn out to as a separate column. Basically, that's kind of to implement. So basically, like with that, when you query like A.B, right, in JSON, you don't have to query the whole column. You just query the separate the subcolumn. So that's kind of like another performance improvement.
I was just curious about this. Is this like configurable, or is it like dynamically picks some columns to be subcolumn?
Like for Snowflake implementation, actually, like internally, it will choose top, let's say top 10 or top 20 columns to generate those kind of sub columns. But I guess for Iceberg, we can use like different rules, or maybe you can do the configuration, right? Depends on which one you're gonna frequently query, something like that. Yeah.
Yeah, because then we can like roll those statistics up to Iceberg level, right, and have more
right, yeah.
pushdown.
Yeah, so that's kind of like basically can give a high level overview. Yeah, for this for the JSON and variant, those kind of questions, maybe we can also have a following discussion in the doc as well.
Awesome. Well, thank you. I think we're at time. So thanks for all the good discussion today, everyone, and we'll see you next time.
Yeah, thank you.
Thanks, everyone.
Thanks. Bye.